Hello viewers, welcome back to the Multimagics channel. So this video it will be an interesting video. So we will be talking about the importance of the tests. So before going into the test, let's just quickly discuss few little aspects of software development. You know, as a part of if you're building any software product, it is important that you follow a certain rules and principles. You need to gather the requirements well, you need to implement, you need to test it well, and then you need to deploy it to the customer. So there are a lot of phases in the software development life cycle, and the software product evolves at each stage. But to maintain this entire software product, for every sprint, for every whatever issue, whatever fix you are doing, whatever new feature you are developing, whatever things you are doing, any little changes should not impact the existing functionality. So that is the first and foremost condition we should remember. So like that, as multiple teams, multiple across the globe works on the single project. So at that time, it is pretty much important to ensure we do maintain quality and we do not break down the existing functionalities, and also we need to ensure the features or the things which were developed, which are currently committed to the product development, is up to the mark. So keeping all these things in aspect from the developer point of view, from the software development lifecycle point of view, it is important for each and every feature you develop, you need to maintain 3 different kind of tests. So let's go into that, what we need to maintain. Yeah, so here we go. So here we need to maintain 3 different tests: unit tests, integration tests, and system tests. So let's see the overview of it. For example, if you have a software module 1 and you have a module 2, or software component 1 and component 2, or and these are the components or classes. These are the components or classes inside this module. So how we can visualize the unit test is, unit test is testing a specific class. So if you have a software module and you have different classes, and you can write how whether the class is behaving, as whether all the methods inside this class are behaving as expected or not. So for that we need to write unit tests for all these classes. So you write a unit test for all these classes, you write a unit test for this particular class, and you can ensure that okay, this individual block is, or individual component in this module is behaving well. At the same time, what if there should be some kind of interaction or some kind of communication between these components or classes? So to ensure okay, these components or classes are working as expected, we need to write integration tests. So integration tests will ensure that okay, this complete module or the interaction between these components or classes is working as expected. And when it comes to system tests, you test as a whole software product. Let's say if you have in your software product, you have 2 modules, module 1 and module 2, you write a system test such that this module is behaving as expected and this module is behaving as expected. So you need to ensure that as a system, everything works as expected. Okay, so this is how we visualize the unit tests, integration tests, and the system tests. So the unit test, as I mentioned, it's the correctness of the individual components. And yeah, one main thing is early bug detection. See, you don't want your system, the bugs detected at the customer level. So the first and the foremost thing is we need to ensure the bugs are detected as early as possible. So it's very, in any software development, once that software is deployed, we need to avoid the escalations. It should not run smoothly. It should run smoothly, and the user interface should be good, and user experience all those things should happen, because the credibility of the organization is there. So we need to ensure this unit test will help us give the early bug detection. And also, trust me, indirectly it also helps the code quality, code maintenance, and refactoring. See, let's say you are testing one particular method inside a class, and that method should have a limited responsibility. such that you can test those functionality of that method. So if you try to mix different goals or different kind of things in one particular function, if it's trying to do more than one, like then in that case it will be bit tough to write unit tests. So it also helps us indirectly to achieve the modularity in your source code. So I just want to repeat this point again. See, if you have a class and you have different methods in a class, if each method, the responsibility of the method should be a bit straightforward. Let's say if you want to add two numbers in the set number, you should add only two numbers. You should not do all kind of subtractions, additions, multiplications, all those things. You combine them in one particular function called compute. So in that case, it is tough to maintain code. It is, which breaks it will some or other how it's tough to, it's not that good practice. So you need to break it down. Addition, one method; subtraction, one method; and the multiplication, one method. So like that you need to maintain for each functionality to maintain each method. So indirectly unit test helps to ensure your source code is maintained well, modular approach is maintained well, the code quality improves indirectly, and also it's kind of refactoring sometimes. Interestingly, yes. So if you are using certain frameworks are available in the market, for example, if you are using GTest, it is necessary that you need to follow the basic inheritance and polymorphism OOPS concepts you should use. So GTest and this you will only support for those type of classes if your design is in that aspect. Indirectly, unit test also helps you to maintain your code in a much more simpler way. So coming back quickly, what is integration test? Integration test, as I just mentioned, it is the interactions between the components, and you can detect the interaction use. Let's say your particular component is working well, this component is particular well, but when it goes together, sometimes this is sending A in one format, this is sending some information in one format, and this is expecting that information in other format. So in that case, you can detect those kind of things. So let's say I'm encoding in once. Let's say class A is sending JSON, but class B is expecting some octet information, octet stream, and you are sending JSON stream here. So those kind of interaction issues you can figure it out early, such that the whole module works as expected. So last is system test. Of course, system test, end-to-end validation, requirement verification, user experience. That's it. System tests are pretty much important. So let's say there's a particular feature in our Multimagics product. Let's say I want to convert an MP4 file to MP3 file. So what are the classes involved in it? What are the modules involved in it? All those things you need to write a complete system test to ensure that all the initializations, memory allocations, conversions, and other features are also working as expected. So everything you need to maintain in the system test. So we will write generally a lot of system tests which does not disturb the system. And what are the frameworks we use for tests? So if your project is C++, if your source code is written in C, since our Multimagics product, our backend code, the native code is in C++, we are using GTest for unit tests. GTest means Google Test. It is a framework, and that framework has a lot of methods, interfaces in it, and we can use that framework to write unit tests for your source code. And there is a GTest and Gmux together. We use it for integration tests. So where if you have a class A and if you want to interact with class B, you can mock the class B operation, or you can mock the class C operation, and you can make some kind of interaction between these two classes and ensure that you don't need to depend upon any other things. Let's say if the class, let's say for example, this class is having some DB connected to DB, always you can mock that DB connections, and then you can directly interact, and then you can write some integration tests. So like the different methods you can talk to in the other class actually. Excuse me. So system tests are meant for Python binding. System tests are meant to entire this system test, and we use a Python binding where C++ methods are exposed to the Python, and you can write system tests. These are not touching as of now. Mostly we'll focus on in this video particularly we'll focus on unit tests, how to write unit tests using GTest. So we'll be focusing in this video in this particular GTest, and as we go on, we'll try to tell more about GMock and the system tests. Okay. So on that note, let's start what actually. So this is the Google test framework. It is a testing framework developed by Google specific requirements, whether you work on Linux, Windows, Mac. So is a platform compatibility is there. You can use it, and then you can go through this documentation, but I will just touch upon the basic things. See, these are the sessions where you can compare your values. So basically, yeah, let me go to quickly the basic thing. Yeah, so let's say you have a class foo and you want to write a test for this class foo, and you include the header file here, and then you just inherit from the test. You write your test class foo test, and you inherit from this framework, and then you write the constructor, you will destructor, and then so see, these are the setup and tear down methods where you can use this particular methods to, if there are anything common between your tests, you can write here written setup and tear, like initializations and deletions, clearing memory, allocation memory for each test case. You don't need to repeat it, you can just commonly address. So this setup and tear down will be calling for each test case written. So how the test cases are written? So it starts with test underscore f macro, and if this macro is there means Google test, that a Google test will trigger. So this will return int main. This is a Google framework. Int main run all underscore tests. So this Google framework will see, okay, what are all the files. It has a test underscore f, and it will run all those tests. And then foo underscore test is the class name. So it will call the constructor here. It will call the setup method, and this is the test name. So at this line, it will call the constructor, and this is the test method, and you just simulate the data, and then you compare it. Okay. So this is about very basic thing about the GTest. It is simply you have a class, and you want to test that class, and you can use few setup functions and tear down functions provided by the Google test framework. And this is how you need to write the test. You need to start with this macro test underscore f, and this is the test class name, and this is the method test name, and then you just write it. So this is about the basic things about the Google test. Now let's see how to set up the Google test on your machine. So let's say these are the instructions for the Linux machine. So you can do it for on Windows and Mac also, provided you have the CMake build tool. So first you need to clone it, and then you need to go to this particular Google test. And by default, Google test comes with GMock and GTest both. So you can either disable GMock, or you can, if you don't give this flag, you can compile both. So yeah, that's how you build the GTest framework after cloning. So now after CMake this, you can give this make and sudo make install. So this will ensure that you build the GMock and GTest libraries from the sources following these steps. So I have also done similar thing here. So basically we have I have cloned the GMock GTest source code here. I have cloned the version v1.40, and then I have all the libraries here. So so this is the GMock headers, and these are the GTest headers, and these are the library files generated. So I have compiled for both GMock and Gmain. So I have maintained a bash script to make it simple here. So these are the build script I have used here. So these are whatever is mentioned in the documentation. I just try to automate it using the help of the script. So with this help of the script, I am able to clone the GMock and then build it, and I ensure all the flags are passed correctly. Okay, so this is how you build the GMock and GTest. So now how to use it? So now this is the interesting thing. So now you need to create a unit test project. So for our Multimagics product, so we have a specific folder called unit test, and then we are trying to test this conversion feature. As you know, in Multimagic's product, we are converting a lot of things, MP4 to MP3, MP4 to other versions, videos, all these things. So we want to ensure the audio conversion class is working properly or not. So that's why I mentioned audio, video to audio. So we have this here, and this is our CMake project. So you need to ensure here you include this package. So this is our GTest. This is where our GTest is there in the dependencies GTest mock. So I'm including all the include files, I'm including the library files, and I'm including all the dependencies here. You can see here I am building an executable here called conversion audio video to audio, and this is the source code, and these are the include directories, and these are the all the dependencies libraries we follow. And this is important, we need to, I'm giving the test name here, conversion A to A. So now you know what is the importance of tests and why GTest is used for unit tests, and how to build it from sources, and how to integrate that into a test project. And now let's look into the source code now. So now this is about how we so this is about, so here I am, just you can just ignore this is not needed. Okay, so here I have a class called MMS conversion audio. So this is a class whose responsibility is to convert. If you given a video file, it will extract audio from it. Okay, so I'll just repeat again. If you given a video file, it will extract an audio file from it. Okay, so now this class has a lot of methods inside it. So for it, since it has a lot of methods, for the simplicity purpose, I just took one method called test init metadata. So now here in this test method, I have this basic test class. I'm inheriting from the test, and I have written like basic. This is the basic pointer, and this is the basic structure I need. And in the constructor, I have it's nothing I'm doing. In the setup, I'm just initializing the memory, and then the teardown I'm deleting it, because these every time you call test, this constructor calls, setup method calls, and once the test goes out of the scope, the structure calls. So that is how the sequence. So now I started one particular method called test init metadata. So I am passing metadata to the source code. So I'm simulating the data. This is the input file, output file, function type, audio bit rate, and then I am calling this function conversion init metadata. And I am for comparison, I'm just fetching the data called get metadata. And now you can compare, okay, whatever variables you passed using the init metadata, whether all those are assigned properly or not. So here I am comparing it as at equal to metadata input file result dot input file result dot. So I'm just comparing all the values one again. And here I am telling that this should be empty if the raw data is not there. So for each method you can pump in different methods. So test cases for one, so this particular method I have one test case. Now for the same method I am writing one more test case called test it metadata with raw info. With the same method I can, if I just enable this particular metadata is raw audio needed, then in that case it should also, the logic should be such a way that that raw information should be there. In that way the raw audio file name should be populated, and I'm validating the same. So this is how you write the test cases. So I'm just keeping it very simple. Now as this list goes on, you can keep on adding a lot of test cases, and then just see what are functionalities inside that each method, and you simulate the data required, and then you keep going like that. Okay, so now the second thing is like, okay, now in the build, now this is the project. You have the CMake file, you have the project, you build it. So inside the build folder I have this executable conversion A to A. I mean, you can just simply run this conversion A to A. It will, but if your IDE is Visual Studio Code, you can install a plugin called C++ TestMate. You can just install this particular plugin, and after installing this plugin you restart your VS Code, and then you go to the settings.json, and then you mentioned testmate.cpd advanced. So you need to see where is your test executables are there. So I'm telling my test executables are under my unit test Linux conversion build folder here, and inside this audio video star.start. So inside this folder my executables are there. That's what I'm telling. So this is my text executable conversion a audio video to audio. Okay. So now if you, after installing this plugin and after setting this settings.json file, and now if you go to this testing, if you refresh it, yeah, you can see here your tests executable are recognized here. So you can simply see I have two tests here. You can just simply click here, your test case will be run, and you can see all the test cases are passed and the amount of time it took to run this test. The interesting thing here is you can also debug the test. So you can go to this particular test init metadata, you can come here, you can just right click here, and then you say debug test. Yeah, so it will hit the breakpoint now. Yeah, so now if you keep continuing, it will go to the constructor. As I mentioned, it first calls a constructor and then calls the setup method, and once that is done, I'll just keep a breakpoint here and then I'll keep continue. So you can see here what is there inside this metadata, and also you can also see what is there inside this result. So it's also good to you can also go inside your source code also from here. So you can also debug the unit tests with the help of Visual Studio Code IDE, with the help of the Testmate plugin, and then you have all the other things installed. So it looks very handy, this particular VS Code C++ Testmate, and then yeah, the different things available here, and you can identify the early bugs. As I mentioned, the main purpose of this unit test, system test, integration test, you can identify the bugs early, you can verify the functionality. It also helps you to refactor the code well and then maintain your code well. Okay, so I hope everyone have enjoyed this unit test video. So see you in another interesting video in the next session. Until then, take care. Bye bye.